It's ready.
Welcome back, Howard Meeks again from St. Mary's Correctional Center. Hopefully by now you've worked with your students looking at the concept of ratio proportions, and then we developed ratio and proportion and used that skill into the first place you see it in geometry, and that's identifying sides of similar figures. Okay? Trigonometry. Tri meaning three, and metry is measure. So basically we're dealing with a three-sided figure, which we all know is the triangle. But not just any triangle, a right triangle, 90 degrees. Okay? On the task test we're going to be dealing with, I'm going to talk a little bit today about trigonometric identities. Basically, the first one I really want to concentrate on is trigonometric ratios. And so that takes us back to, what's a ratio? It's simply comparing two numbers using division. So I'm going to take sides, or the numbers of the lengths of my sides in a right triangle, and I'm just going to simply compare them using division, or essentially making a fraction. Also, let's remember and review, when we talked about similar, it was two polygons with congruent angles and sides are proportional. The key here is trigonometry, it has to be a right triangle. So you'll either see the identifying square, letting you know it's a right angle, or you'll see 90 degrees, or again, as you saw the Pythagorean theorem, sometimes they may give you the smaller angles and know that when you add up it should equal 180. So you might see a 30 and a 60, and they're expecting you to remember that concept and figure out that that is a 90. But so the concepts we're going to be dealing with then is idea of a ratio, and we're going to deal with the fact that these trig ratios work because of the fact that the right triangles are similar. What do I mean by similar again? Congruent angles. In other words, even though my side lengths are different, all three angle measurements are the same, and therefore my sides are proportional. Okay? They shrink or grow in the same amount. Without that, these trig ratios wouldn't work. So let's take a look. Trigonometric ratios. Remember I said ratios are comparing something using division. So I'd like to start off with my students with this right triangle and say, how can I compare these using division? So normally I ask my students, and I'll say pick a side. And pick a figure. You got a star, my little heart down here, or my funny greenhouse.
The star.
Okay, so I'm going to think, so we're going to do star over compared to, and we'll make it a heart. Okay? Or I can say, give me another one.
The arrow and the heart.
Over heart. Or we could switch it around several ways. We could say heart over star. Now, Coach, what are you doing here? I just want to show you real simply, that's all we're doing. We're comparing this side to this side. When I start putting numbers in right away, my students start wanting to come up with fractions and start getting a little off track. I want you to simply understand that trigonometric ratios, I'm just simply comparing one side to another in a ratio, fraction bar. Okay? Well, it's all in the name. So when you start seeing, and here is the trigonometric identities that you'll find on the task readiness worksheet or formula sheet, and you'll see it starts looking, Coach, what's all this? Well, remember, we were comparing heart to star and whatever, and it didn't matter. Well, I didn't choose it, it's all in the name. Somewhere along the line, mathematicians decided if I can compare this side to this side in a certain way, we're going to call it sine. If we compare another side to the hypotenuse, we're going to call it cosine, and opposite and adjacent. Where do all these words come from? So let me simplify. First of all, let's take a look. They've abbreviated. OPP stands for opposite. Hypotenuse, you should have heard this term before. Okay? Okay? And the last one is adjacent. Okay? You do not, as a student for the task test, you do not have to memorize this. It will be in a formula sheet. When I had it in school, they made us remember it, and we had Chief Sokotoa sign, the OH Sokotoa, or I've heard orange hippos always have orange ankles. So there's several mnemonics to learn this, but fortunately for you, you don't have to memorize it. It will be on your formula sheet. Okay, let's take a step back and say, well, Coach, what do you mean? Well, this says sine of theta. Greek symbol just means the angle. What angle? And it could be named different. In my right triangle right now, I have an angle A and an angle B. Okay? So if I asked you, what is the sine of angle A, I'd be asking you to tell me what sides am I going to compare a certain way. So I go to angle A, and I want to set it up where I have a ratio, so I need my fraction, and I want the opposite. So if I go to A, the opposite straight across, and so what is opposite A? What number?
4.
4. So we're going to put that on top, because that's what it wants us on top. And the hypotenuse, and we should know from Pythagorean's theorem, in the video on that, that the hypotenuse is always your longest side, or always the side across from your right angle. So that number would be 5. So the sine of A, or how I'm comparing it, would simply be 4 over 5. Okay? And we'll move on. What's cosine? Well, depends on which angle I'm talking about. Remember, a short brief note, sine, cosine, and tangent is always from one of the acute angles, or one of the angles that are less than 90. You never start from the 90. Okay? So when they're asking you the sine, cosine, or tangent of a measured angle, it will always be from one of the smaller angles of the triangle. Okay, cosine. Cosine of A, now I'll abbreviate, you'll see it. You'll see sine, cosine, and tangent abbreviated just to 3 letters a lot. I don't want you being confused with that. Cosine of A is adjacent. So I'm going to come to A. What does adjacent mean? Adjacent means right beside. So I have 2 sides right beside A. This one and this one. So which one is my adjacent side? Well, remember that the one across from the 90 is always the hypotenuse. So even though it might be touching your angle or right beside it, you can't change it. It already had a name, so that's your hypotenuse. So in this case then, that would be my adjacent side to angle A. Hopefully that makes sense to you. So my adjacent would be 3, and again then over my hypotenuse is what number?
5.
5. So simply, if I asked you what is the cosine of A, I'm simply comparing 3 over 5. Okay? All right, and last but not least, I'll try to make these a little smaller. 4 over 5, 3 over 5, okay? And tangent then, we're going to go back to angle A. And tangent would be the opposite. Again, we identified that as straight across to the adjacent. So this would be 4 over 3. Well, Coach, you have cosine, sine, and tangent again. Well, what if I started from the other angle? Okay, let's see how it changes. So what is the sine of B? I would go to B and look at my chart, and it says opposite. So what is the opposite of B?
3.
3. And then my hypotenuse would remain 5. If you notice one thing, if you notice that the sine of B, 3 over 5, is the same as the cosine from A. So when you go opposite, your sine and cosine reverses. Okay? And therefore then, if we know cosine of B, all right, we'll go to B, adjacent, right beside with the hypotenuse, so it's 4 over 5. And again, you notice that was the same as the sine of A from the opposite angle. And last but not least, tangent, opposite, okay, over adjacent, and you'll notice that the tangent from the opposite angle is just reversed. Okay, you don't have to remember that. What you do need to know is how to find or how to set up your ratio. Okay? Simply look at your formula sheet and you can follow it. Sine is opposite over hypotenuse, cosine adjacent, hypotenuse, and tangent is opposite over adjacent. I believe once you understand what those abbreviate for, you don't have to be an expert at trig to be able to track them out. Okay? Then, if you remember, when I'm talking about similar figures, I said that we also talked about proportional. Proportional are two ratios that are equal. In other words, they'll simplify the same. Okay? And that concept is key. So if you would take your calculator and just simply divide, 4 divided by 5 would reduce to 0.8. 3 divided by 5 would reduce to 0.6. Okay, and obviously these would be reversed down here. Okay, 3 divided by 4 would be 0.75, and this should be 1.3 repeating. 4 divided by 3, but not to confuse myself, I'll double check, and I was right. Okay, so we just simply compared the sides, and you can also see if we had it in decimal form, which we will use and you will see again when we develop into problems, but I want you to see where it comes from. We just simply took the sides and compared them, and then we what this means is divide, comparison using division, we simply divided, and that gave us our simplified ratios. Okay, well coach, let's move on a little bit. How's this going to work, or how does this develop in trig ratios? Well, remember, when we dealt with similar figures, we said that they're going to grow the same, okay, or shrink the same, okay? And we also know that if they're similar, that all the angles are congruent and all the sides are proportional. So what we're able to understand is then, if these two angles are the same, and I have a 90, then this angle must be the same. And therefore I have 3 angles that are the same, and based on that fact, then I know that my sides must be proportional. And if you would check this, you would realize 12 divided by 3 is 4, so 9 divided by 3, yes, is 3, 15 divided by 3 is 5, and you realize that all right triangles with congruent or similar angles, then their sides are going to be proportional. And remember, when we were talking about ratio of proportion, if I know 2 or 3, then I can solve for the missing side. And we're going to be able to develop that and use our trig identities to help us solve for missing sides. Okay, here's a good time for us to stop and slow down a second. I like to use Math Triumphs book by Glencoe McGraw-Hill, published in Columbus, Ohio, copyrighted 2010 in my classroom. And here's just a chance for you to go slowly with your students and review key concepts. The sine function, again, was the length of the opposite side over the length of the hypotenuse. Cosine is the length of the adjacent side over the length of the hypotenuse. And again, your tangent ratio is the length of the opposite over the length of the adjacent. Again, maybe looking at this will again help your students understand the concept. And now's a good time. I work with my students by just providing them problems with all 3 sides, and I would mark an angle and have them practicing identifying sine, cosine, and tangent and setting up the simple ratios. So now, as an instructor or as a student, it would be a good time to practice, and then when you're ready to move forward, just continue on, and we'll keep on moving with the trig identities. Okay, hopefully now, as an instructor, you've had time to work with your students and got them a little bit comfortable with just using the task readiness sheet, the formula sheet, and so they can look and take sine and be able to identify their sides. The opposite, find the hypotenuse, and find the adjacent sides. Okay. One other skill that, one concept I want them to realize, so often on the right triangle, they will have a angle already identified. And as you see in this right triangle, I'm going to have my acute angle of 45, and over here I have an acute angle of 30. Well, understanding the idea of similar figures and that all right triangles with the same angles would be similar, that's going to be a key concept. So I know that every right triangle that has a 45-degree angle, hopefully your students would also know that this one's 45, okay, that every right triangle with a 45-degree angle, that when I have sine, what was sine? Opposite over the hypotenuse. That when I take the opposite side over the hypotenuse, okay, that it will reduce down or simplify to the exact same ratio. How many? Every 45. Okay? Again, in every 30-degree angle. So this would be, I would hope they would know that this would be 30, 60, 90. So every 30, 60, 90 triangle then would be proportional. So once you know that, you'll be able to help identify sides. Okay? Remember, when I did my division, I had a decimal. Well, we're going to start looking at the calculator here soon and start using the trig functions on the calculator, and I'll show you how all these concepts start tying in, and we'll put them into real practice. Okay? So let's begin doing that. Well, Coach, my teacher says when I see a right triangle, that's Pythagorean's theorem. And I don't want to confuse you and tell you that, as a student, that your teacher's wrong. What you got to understand is this. Pythagorean's theorem works when I have side lengths, when I have at least two side lengths. Okay, so if I had this side length and this side length, I could find the third, or the unknown, using a squared plus b squared equals c squared. And you'll find that formula on your formula sheet. Okay? Or if I had two side lengths where I had the hypotenuse and another side length, then that would be c squared and b squared, and I could subtract and take the square root and find the other one. Well, what's the problem you're finding here? And this is where I tell the students, this is when you know you need trig. I have, normally you'll find an angle identified, and you'll have two sides labeled. Okay? One of them you have to have a length, at least one, and then we're looking for an unknown. Okay? Without that third side, we can't use Pythagorean's theorem. So this is when you're going to have to use trig, the trig identities, or your sine, cosine, and tangent functions. Okay? Well, taking this slow, and we'll practice together. Coach, what do you mean? Well, I have an unknown. So the first thing I tell my students when I have the unknown, I obviously need to solve that. Okay? And I want to use that using trig ratios. So that means I'm going to have to set it up like we did before. Okay? In a fraction. So, if x is over here, what side is it? From my 45, it would be the hypotenuse. So I need to use a trig identity that involves hypotenuse. Okay? And if we go back real quick and look, that means I'm either going to be using sine or cosine. All right? So I've narrowed it down. Well, which one now, Coach? Well, that's the number I have. So I go across and I look, and the only number I have is in which direction, opposite or adjacent?
Opposite?
It is opposite. Don't let your eyes fool you. Don't try to overthink the problem. So, we know by looking at your formula sheet that sine is opposite over or hypotenuse. Okay? And luckily through the help of editing, I said hypotenuse, but my hand wrote ADJ adjacent, and I don't want any confusion. So when you see me work the rest of this problem and talk about this slide, please realize you're going to see ADJ on what I was going over, but it is opposite over hypotenuse. And I thank you for your patience and on our little video. So therefore, I know that the sine of what? 45 degrees, because it's the same in every right triangle with that degree measurement, would equal 12 over x. Okay? And I gave you a tough one to start off with, and we'll set up this other one, and then I'll go ahead and show you the calculator. I'll bring it up close and let you see how we're going to solve it. So it's simply understanding what we've learned. We know that if I can find the sine of every 45-degree angle, okay, and then on this one it's going to be 12 over x, and we're going to use that information. Okay, over here, let's take a peek. This is my short angle. I need to solve for x. So where is x? X is opposite. So I know that I need to solve for opposite. So the only thing I'm going to deal with opposite on top would be sine. So the sine of 30 degrees in this problem would be x over the hypotenuse, which is 35. Okay? And at this point, we're going to use algebra, but for some of you that are working on your algebra skills or whatever, I'm going to show you a little tip, and then after we go on, don't get caught up. I tell my students, don't get excited if you don't get it the first time. I'll do enough problems here in the video that you start getting the pattern, and then once you get the pattern, you can practice with your instructor, and you'll be comfortable when we're said and done. Okay? So, I'm going to work this problem first. Knowing algebra, what is the opposite of divide? I'm dividing my unknown. So the opposite of divide is multiply. So I'm going to multiply by 35, and that cancels that and leaves my x, which I'm trying to solve. And so I'm going to take this funny thing that we haven't finished talking about, sine of 30, and I got to multiply. What I do to one side, I do to the other, and I'm going to multiply it by the length of 35. At this point, I'm going to try to move up a little bit closer for you. Okay, get my calculator set up, and you'll see my keys, and you'll see that we have a sine, cosine, and tangent key. All right, and then later on we're going to talk about using a second key, but that's at the end of the video. So we're going to hit sine 30, and you'll see in parentheses. So that's sine 30 degrees. Make sure you're in the right mode, and when you go to your mode, make sure you're in degrees. Okay. And I'm going to hit enter, and you notice a decimal, 0.5. Where'd that decimal come from? Remember, when we compared the two side lengths at the beginning, like 3 over 4, or 3 over 5, and then we did the division, and we got the decimal, 0.6. So every right triangle that has a sine of 30 degrees, that opposite over hypotenuse would be 0.5. So that's what they're converting for you. So there's our 0.5, and then we got to finish the problem times 35, which was the length in our problem, and we're going to get 17.5. Okay? So, multiplying out, x equals 17.5, and there you were able to find your side length without using Pythagorean's theorem, based on the fact that all right triangles with a 30-degree angle are similar proportional. Okay? Now, I said I'd come back to this problem, and again, if you're not comfortable with algebra, I'll teach you the little shortcut. So I do not like my x in bottom. Okay? So the opposite of dividing this number by x would be to multiply by x, and that's going to cancel and leave me 12. And what I do to one side, I got to do the other. So sine of 45, and now I'm going to multiply it by x, or times x equals 12. Well, coach, you moved it over, and now we still got x tangled up with something. So now sine of 45 times, the opposite of multiply is divide. So I'm going to divide by the sine of 45, and that cancels. And now I've got the x by itself, equals, and so I'm going to take 12 and divide it by the sine of 45 degrees. And so now I'll come up, 12 divided by sine 45, enter, and we get a number of 16.97, or approximately a length of 17. okay? And again, we had different side lengths, but every 45-degree angle would have that constant ratio, and knowing that fact is able to help me solve it. Well, I said I'd give you a tip, because I know some of you are probably going like many of my students the first time I show them this, scratching their head, and let me give you a little tip. Whenever the x is on top, all you have to do is multiply. Take your sine of your degree, or your cosine or tangent, whichever function we're using, and we'll get into that a little deeper. You take that and you multiply by your length. Okay? If you notice, when the x is on bottom, and we did all the algebraic manipulation, all we did was take our side length we had and we divided it by our degree, or our sine of 45. Okay? And that's a quick way I teach my students. Whenever you set it up, if the variable for the side you're looking for is on top, you're going to multiply. If the side you're looking for is on bottom, you're going to end up dividing. Okay? And hopefully I do have some more problems set up so you can see what I'm talking about. All right. The best way that I know to learn basic trig is just to start doing, for me, giving some examples to my students and working with them and letting them practice setting it up. And again, it never hurts. I posted again your trigonomic identities, or our functions, sine function, cosine, and tangent function. Okay. I've talked in other videos. I'll mention again today. I have a lot of free worksheets that I have available, a resource I brought in my classroom from kudasoftware.com. You can also purchase their package and have a lot more things that you're able to do as an instructor. But what I like about this, it gives you various problems, and it gives, as an instructor, you can have the answer key, and so you can allow your students to practice some things and then have answers set up. Okay? So it says find the missing side, round to the nearest tenth. So the first thing, again, just to get used to it, as a student on a test, I'm looking, hey coach, right triangle, my teacher says Pythagorean theorem. Oh, wait a minute, what was that you told me? I need to know at least two sides, and so I know that this side length is 10. We're going to be looking for this side length, and I don't have at least two sides. So we cannot use Pythagorean's theorem. And so that old adage, I'm always using Pythagorean's theorem, doesn't work in this right triangle problem. So the next thing I got to do is start looking, what am I looking for? So I have to find my unknown, so I have to pick either sine, cosine, or tangent that's going to help me use this side. So I start from the only angle they gave me, since they gave me an angle and a missing side and one side. So I'm going to come from this angle, 27 degrees, and I know I'm going in what direction? Opposite. Okay, so I have opposite. And the other side, the side that they're giving me, is right beside it, or we call it what? Adjacent. Coach, why wasn't the hypotenuse? Remember the hypotenuse is always the side across from the 90. And a lot of my students will mark that one right away, so that way they don't get confused. Okay? All right, coach, now what are we going to do? So I know something of 27 degrees, that's the angle, equals, and I have to use opposite and adjacent. So I come over here, and which function uses opposite and adjacent? And it's tangent. So which way do I have to set it up? What goes on top?
X.
The opposite. Very good. So that's going to be the x on top. And so the adjacent would be beside it, which is 10. So, and I know what ratio I got to use as tangent. So tangent of 27 equals x over 10. Remember my tip? You're going to start getting used to it. If the x is on top, then I'm going to multiply. So multiply by 10. So I'm going to simply multiply by 10. So again, coming in, tangent, 27 degrees times 10 equals 5.09, or about 5. So x is 5. Seems real complicated. Once you get practiced and understand where we're getting the information from, it's simply using your calculator and plug it in, and you'll gain confidence. Let's look at a few more. Again, another problem. Again, I'm keeping our little guide here. As you get more and more used to it, you won't need to look at your guide so often. but again, I like my students to have it so they're not guessing. Okay? So I look at this problem. Can I use Pythagorean's theorem? No, because I only have two sides, one unknown and one known. I would have to have the other side. So that means I'm going to have to use my trig identities again. So I know something, don't know which function I'm going to use, something of 39 degrees, okay? And I have my hypotenuse, and I have to look for x, and x is in which position? Right beside or adjacent. So I'm going to have to find my trig function that uses adjacent and hypotenuse. Which one uses adjacent and hypotenuse? And hopefully you would identify cosine, which is adjacent over hypotenuse. So I'm going to use cosine, theta, which is simply your measurement, so 39. So cosine theta, or cosine 39, is the adjacent. Adjacent was x, and my hypotenuse was 7. Again, my variable's on top, so I'm going to multiply. Multiply both by 7 to find my x. So cosine 39 times 7, and we're going to get an answer 5.44, or x is approximately, you'll see the little squiggly, 5.4. I believe the instructions were to the nearest 10th. Okay? And again, another problem. So we're just going to have to keep working on and getting practice. So I need to find something of 46 degrees, something of 46 degrees, okay? And now I'm going to identify my sides. I have my opposite, and I'm looking for, I don't know, my hypotenuse. So opposite and hypotenuse. So as you can see, we're going to use opposite over hypotenuse, or the sine function. All right, so I'm going to identify sine of 46 degrees is the opposite over hypotenuse. So I need the opposite, which was 8. And my hypotenuse was the unknown, or what I was looking for. Remember, here's where I said be careful. When the variable's on top, we simply multiply it. When it's on bottom, to cut through all the chase, we're going to divide. So we're going to take the number we have, or 8, and we're going to divide it by the sine of 46, or that constant ratio that every right triangle with a 46-degree angle has. So let's look. The number on the side I have, 8, divided by sine of 46 degrees. Bingo, bango. 11.12, or approximately 11.1. And as you can see, when we dealt with Pythagorean's theorem, a lot of the problems were real nice and neat. 3, 4, 5. 9, 12, 15. And in the real world, they're not going to come out real neat. And as you can see, we can identify. What's one job that you might see trig used on a regular basis? Surveyors. Surveyor might walk a certain distance from a stake, shoot an angle across at another stake, and then be able to use trig to calculate distance without having to climb feet, yards, even miles. Okay. Some surveyors can they're actually doing it from planes now and stuff like that. So but that's an example. All right, again, Coach Meeks here with the grace of editing. We're going to zoom in on the worksheet that I'm covering. I do identify the numbers as I work them, but just so you or your students can have a closer look up and be able to write it down, we're going to zoom in here again on the 8 problems that I'm talking about to follow up. So slowly, problem 1, 2, 3. And again, those are all just finding ratios. Problem 4, 5, 6, and a couple word problems that you might expect or can find on a test. problem 7, and problem 8. And lastly, at the bottom, again, the text that I like to use as a resource in my room, Math Triumphs from Glencoe, McGraw-Hill. My version is 2010, and you'll see the answers for the problems that I'm not going to work in the video. And there's your answer key to help you out. Okay? Basic trig in one job. All right, as you can see, again, the book I like to use, Math Triumphs from Glencoe McGraw-Hill. So here's a little progress check. I'm going to work a few. I'll show you how to set up the other word problem, and that will allow your students to do some work, and then I'll leave a few for them to practice on their own. All right, so let's take a look. The first one they're saying, find the tangent of A. So I'm going to go find angle A, which is here, and tangent. And if I remember, going back at my trig functions, tangent was opposite over adjacent. So I'm going to find opposite over adjacent. And so my opposite is 12, and my adjacent is 35. And simply, that's all I'm doing. I'm comparing. Remember, trig ratios are basically comparing, so I'm comparing my side lengths. And if you divide that, you would get a decimal, and that's what would be constant with every angle, that degree measurement, but they didn't give us that degree measurement. In this problem, they're simply asking me to find what is the tangent of A. So I will allow you to let your students go ahead and do that for problem 2 and problem 3. Okay? Working on, find each missing measure to the nearest tenth. So I'm looking for a side measurement, okay? And again, to the nearest tenth. So it's like this problem is similar to ones I just got done working. I know I have 67-degree angle, so something of 67 degrees, okay? And I'm missing that value right beside it, or which is adjacent. So I know I need to use my function that has adjacent, and my hypotenuse is across from the 90, so that therefore this must be opposite. Okay? And I'll clear that up a little bit. I know it's a little bit smaller. So you can see that this side length is opposite. So opposite and adjacent would be tangent, and tangent of 67 would be opposite over adjacent. So opposite was 6.3 meters. Adjacent is what I'm looking for. So where's my variable? It's on bottom. Remember my little tip? Take the number you have or the side length you have. When the variable's on bottom, you're going to divide. So I'm going to divide that by the tangent of 67. Again, 6.3 meters, 6.3 divided by, we determined it was tangent, 67 degrees, and my length was 2.67, or about 2.7. So this would be 2.7. Checking the validity of your answer, if you can look, obviously my hypotenuse is the longest length. Obviously this looks longer than this side seems shorter than that one. So this is 6.3. I would expect my answer to be smaller than 6.3, and it was. Sometimes you get your numbers in backwards, or maybe you forgot to divide and you multiplied and you got a big number, and then when you put it in and say, wait a minute, Coach, that doesn't make sense. So you can check your validity of your answers once in a while. Okay? Again, I will allow your students to set up these problems and work them. This is 46, in case it's hard to read, 46 degrees, and you have a hypotenuse of 5 yards. And down here you have your angle of 18 degrees, and your opposite is 3.4 inches. Okay? I said I would go ahead and work, and I will, a couple word problems. Quite often on the test, you will see them set it up in a word problem. I tell my students to make a picture. All right, now we're going to look at a few word problems that you may typically encounter, asking you to set it up in trig functions. The first thing I would like to tell my students is make sure, draw a picture. It doesn't hurt to draw a mental picture. It helps get your right angle set up in a visual image for yourself. So let's take a look. A plane taking off ascends at an angle of 30 degrees. So we're going up, ascending, not descending. And from the ground is 30 degrees. Okay. And they want to know how far does it travel across the land to reach an altitude of 15,000 feet. So we're going to get 15,000 feet high. So going up at that angle until you reach, maybe cruising altitude or whatever for that flight. We want to know how far that plane went from takeoff. Okay. Of course, we're going to be straight up and down to the ground, so that's where we're going to use. Note it's a right triangle, and we're looking for this distance right here. All right. So taking a peek, my angle's 30 degrees. I know that this height is opposite, and my unknown, or what I'm looking for, is right beside or adjacent. So again, the function that uses opposite and adjacent would be tangent. So I'm going to say the tangent of 30 degrees is opposite, which was 15,000, over, and I'm looking for my unknown. If you remember my tip, then my variable's on bottom, so I'm going to divide. See if I can slow this down a little bit and give you a close-up. So we're going to have 15,000, which is our known distance, divided by the tangent of 30 degrees. And you'll see 25,980.76. We're about 25,980 feet. 25,980 feet. So, as you can tell, a little over 5,000 feet in a mile. So we're looking at a little over 4 miles. So it takes that plane a little bit of while from where it started, covering land to get up to cruising altitude. But again, an example of a word problem and how we're going to use trig to solve it. Okay? The last problem, I'm not going to do the calculator work for you. I want to go ahead and help you set up the visual, and then I'm going to allow you to work it. And again, instructors, you've got the answer key to the problems I'm not working, 2, 3, 5, 6, and 8. Okay, let's look at problem 8. Okay, a skateboard ramp has a 25-degree angle with the ground. So here's my ground, and I'm going to have a skateboard ramp at a 25-degree angle. Okay, if the ramp is 10 feet long, well, that board that I'm using, of course we did that as a kid, is 10 foot. So it didn't ask how far from the wall. It's going to be 10 foot, so I can reach out, and it wants to know how high off the ground will the skateboard would be when he leaves the ramp, or the skateboard when it leaves the ramp. So how high? Well, if my ramp was 10 feet at a 25-degree angle, and I need to know how high, so I'm not sure. And that's going to be my unknown. Okay? So there's your numbers there you're going to use. You're going to find something of 25 that involves opposite and hypotenuse, and hopefully you have no problem setting it up and using what I've taught you to find your answer. We've covered a lot, and I hope we haven't covered too much, but there's one last little thing that I want to take a look at. And remember I said that there's a green button that I want to show you in the calculator. I'm probably not going to do enough problems, maybe to make you comfortable, but hopefully you get the idea. Okay? Well, Coach, what happens if they don't give me the angle measurement, but they give me 2 sides? Now, we're not asking for the 3rd side. If we were asking for this missing side here, you would not need a trig function, because now we have 2 knowns looking for the 1 unknown. So then, as we mentioned earlier, we're going to use Pythagorean theorem. But they didn't ask for the missing side. They wanted to know what the angle measure is. So wouldn't it be nice, once I had an angle, I could use it to find that constant to find the side, wouldn't it be nice if I already had the ratios or the two sides to compare to go back and find the degree measurement? And that's what we're going to talk about here. Okay. So here I am at angle A, and I have two lengths known. And what positions are they in? From angle A, my 12 is what? Opposite. And obviously 15 is my hypotenuse. So which trig function uses opposite over hypotenuse? We can never talk about it too much. And hopefully you look at your sheet and you realize it's sine. So I need the sine of A. Okay? And I know that the sine of A is the opposite, 12 over the hypotenuse, or 12 over 15. And if we take 12 over or divided by 15, we'll find a constant of 0.8. So we know that the sine of A equals 0.8. Well, wouldn't it be nice if I could go backwards and find that angle? Once you find that constant ratio, we can do that. So I told you we're going to use that green button, so you're going to hit second, and we're going to use sine. If you look right above the sine key, hopefully you can get zoomed in here, you'll see sine -1, or I call sine inverse. We're going backwards. All right, sine inverse, and you're going to put in your decimal of 0.8. So I'm going to go backwards from 0.8 to find that angle, and you see it's 53.13, or about 53 degrees. Okay, a nice little function. Okay, that green key and going backwards. Let's take a look at a few more problems, and I think I've got a good variety over here. What of A? Angle A, and let's see what they gave me. We have the hypotenuse, so I have hypotenuse here and adjacent. So which function uses adjacent and hypotenuse? It's going to be cosine. Cosine is the adjacent over the hypotenuse. In this case, it's 3 over 5. So I know cosine of A is 3 over 5. 3 divided by 5 is 0.6. So cosine of A is 0.6. So I'm going to do cosine inverse of 0.6 to go backwards to find my degree measurement. So let's do a few more problems together. Second key, hit the cosine, so that way we get the green, which is cosine inverse of 0.6. And you see that's 53.13. Okay, or 53 degrees. Coach, that's kind of unusual. Well, remember I said the sine of 1 is the opposite, and if you noticed, 12 and 15, you would figure out this is 9. You're going to find out that these sides were proportional once if you figured out the missing sides using Pythagorean theorem. So, just a neat little thing, and I want to show you that it all ties together again. But just remember, cosine is adjacent over hypotenuse. All right, let's go. I picked a different angle, and I picked something that didn't come out so nice and neat, so no more little tricks today from Coach. All right, let's take a look. So I want to find the degree measurement. I'm looking for the degree measurement of angle B. So whenever you're going back looking for degree, you're going to use that inverse key or the green buttons. Okay? And from B, I have opposite and adjacent. So again, opposite and adjacent is tangent, so we're going to say the tangent of angle B equals 14 over 18. Okay, clear? 14 divided by 18 gives me a decimal of 0.77 repeating, and I'm going to leave it like that. Okay, and so now I'm going to say, Coach, what if I went backwards or took tan inverse of 0.7 repeating? So I'm going to go second tan inverse, and you're going to see me bring my answer back. For some of you that haven't seen that, second answer, ANS. I'm going to bring my answer back, show you that calculator skill, and that comes out to 37.87. We're going to round that to 38 degrees. right, one last problem, clean the board up. Hopefully you can do this a little bit on your own. I'll go slower, let you try to work this, okay? So we're going to find the angle of B. So I need to find something from angle B. I look, this side length I was given is opposite. And the other side length is across from the 90, so we should know by now that that's hypotenuse. And so opposite over hypotenuse is sine. So the sine of angle B is opposite, or 4 over 10. Remember that beginning skill we practiced where you just simply had the side lengths and had them finding? Now you see why we practice that, because that simple skill is going to be used again. Just find it and line up your ratio or fraction the way you need to. Opposite over hypotenuse, 4 over 10. And if you divide that, 4 divided by 10 is 0.4. So I'm going to say sine inverse, right? I want to use, or the sine, I'm sorry, the sine of B equals 0.4. So sine inverse, I want to go backwards using 0.4. It's going to give me the angle measurement I'm looking for. And that'll be the last problem we're going to work today. Second, sine 0.4, enter, 23.57, or about 24 degrees. Okay, I know we've covered a lot. I hope you see that Pythagoras theorem doesn't always work when you see a right triangle. I hope I simplified it a little bit, took some of the mystery. When you hear the big word trig, it's like I can't do that. Trust me, my students are learning and they can. The fortunate thing is you don't have to remember some of the mnemonics like Chief Sokoto that I had. You're going to have your formula sheet right there with your trig identities. So it will help you set up. Just as long as you remember how to find opposite, adjacent, and hypotenuse, you're well on your way to understanding basic trig. I hope this short video helps you. And again, if you have any questions, you can always contact me here at St. Mary's Correctional Center, 304-684-5500. My extension number is 315. Thank you and have a great day.